NEC Article 230.71 states that disconnecting means shall be provided in accordance with the requirements of this section for each service, feeder, and branch circuit required to be protected by an overcurrent protective device. This article does not specify that all disconnects must be located in one place. NEC Article 230.72 addresses situations where a feeder supplies several distribution panel boards or other sub-distribution equipment and is protected by a single overcurrent protective device. In such cases, the disconnecting means for each distribution panel board or other sub-distribution equipment shall be located in the panel board or other sub-distribution equipment. This requirement implies that disconnects for services and feeders do not necessarily have the same location restriction. NEC Article 240.18 pertains to situations where a feeder supplies one or more unit equipment and is protected by a single overcurrent protective device. In this scenario, the disconnecting means for each unit equipment shall be located at the equipment. Again, this article mandates specific disconnect locations for unit equipment but does not extend a similar requirement to feeders supplying a main distribution panel. Regarding other considerations, the power company's inspection and approval of the installation are significant. This approval suggests that the installation aligns with the power company's requirements and safety standards. The installation's compliance with all applicable NEC requirements for safety and accessibility is also crucial. If the existing installation adheres to these requirements, it strengthens the argument against relocation. The financial burden and disruption associated with moving the disconnects to a single location should also be considered. If relocation is prohibitively expensive and disruptive to the building's operation, it provides a practical argument against the inspector's interpretation. When addressing the inspector, firstly, clearly articulate the relevant NEC articles that support the existing installation's compliance. Emphasize that these articles do not mandate a single location for all service disconnects. Secondly, highlight the power company's approval of the installation as evidence that it meets established safety and operational standards. Thirdly, reinforce the point that the current installation is safe, accessible, and in accordance with NEC requirements. Fourthly, clearly communicate the significant financial implications and disruption that would result from moving the disconnects. If necessary, explore the possibility of requesting a variance from the local authority having jurisdiction. A variance is a formal request for an exception to a specific code requirement when strict compliance is impractical or creates undue hardship. To bolster the argument, gather detailed information about the calculated load for the building. In this case, it's a little over 2900 amps. Having this figure readily available helps demonstrate the scope of the electrical system and the potential challenges of consolidating all disconnects in one location. Research the specific requirements and interpretations of the NEC in South Carolina, as local amendments or interpretations may exist. Understanding the local context can help tailor the arguments more effectively. Consider obtaining a second opinion from another qualified electrical inspector or engineer. An independent assessment can provide additional support for the existing installation's compliance with the NEC. Document all communication with the inspector, including dates, times, and the specific points discussed. Maintaining a clear record of these interactions can be helpful in resolving any disputes or misunderstandings. Explore alternative solutions that might address the inspector's concerns without requiring a complete relocation of the disconnects. For example, consider installing additional safety features or providing enhanced labeling to improve clarity and safety. Be prepared to negotiate with the inspector to find a mutually acceptable solution. A collaborative approach can often lead to a more satisfactory outcome than an adversarial one. In addition to the NEC articles already mentioned, consider reviewing the following sections for related information. NEC Article 225 covers outside branch circuits and feeders, and it may contain provisions relevant to the installation of disconnects for exterior equipment. NEC Article 408 addresses switchboards, switchgear, and panel boards, and it may provide guidance on the location and arrangement of disconnects within these types of equipment. NEC Article 230.95 pertains to ground fault protection of equipment, and it may have implications for the coordination of disconnects and overcurrent protective devices. When presenting the arguments to the inspector, ensure that the presentation is clear, concise, and well organized. Use visual aids such as diagrams or photographs to illustrate the existing installation and explain how it complies with NEC. Be respectful and professional in all interactions with the inspector. Maintaining a positive and cooperative attitude can help facilitate a more productive discussion. If the inspector remains unconvinced, consider escalating the issue to a higher level within the local inspection authority. In some cases, a review by a senior inspector or supervisor may be necessary to resolve the dispute. If all other efforts fail, consult with an attorney who specializes in construction law or electrical code compliance. An attorney can provide legal guidance and represent the interest in any formal proceedings. Throughout the process, prioritize safety and ensure that the electrical installation meets all applicable requirements to protect people and property. Even if the existing installation is code compliant, it's important to address any legitimate safety concerns raised by the inspector. Remember that the goal is to find a solution that is both code compliant and practical, while also ensuring the safety and reliability of the electrical system. The NEC is a complex document, and interpretations can vary. By thoroughly researching the code, gathering supporting documentation, and communicating effectively with the inspector, it's possible to resolve the dispute and avoid unnecessary expenses. The key is to remain informed, persistent, and focused on finding a solution that meets the needs of all parties involved. Furthermore, consider the long-term implications of any changes to the electrical system. Ensure that any modifications are properly documented and that the building's electrical drawings are updated to reflect the new configuration. This will help facilitate future maintenance and repairs and ensure that the electrical system remains safe and compliant over time. It's also important to educate the building's occupants about the electrical system and its operation. Provide them with information on how to safely use electrical equipment and what to do in the event of an electrical emergency. This can help prevent accidents and ensure that the building's electrical system is used responsibly. In addition to the technical aspects of the code, consider the aesthetic impact of the electrical installation. Ensure that the disconnects and other electrical equipment are installed in a neat and professional manner and that they are properly labeled. This can help improve the overall appearance of the building and enhance its value. When selecting electrical equipment, choose products that are known for their quality and reliability. Using high-quality equipment can help reduce the risk of failures and ensure that the electrical system operates safely and efficiently. It's also important to ensure that the electrical system is properly maintained. Regularly inspect the disconnects, wiring, and other components to identify and address any potential problems before they become serious. This can help extend the life of the electrical system and prevent costly repairs. If any electrical work is required, always hire a qualified and licensed electrician. A qualified electrician has the knowledge, skills, and experience to perform electrical work safely and in accordance with the NEC. This can help ensure that the electrical system is installed and maintained properly and that it meets all applicable safety standards. When working with electricity, always follow safe work practices. Wear appropriate personal protective equipment, such as gloves and safety glasses, and never work on live electrical circuits. This can help prevent electrical shocks and other injuries. Remember that electricity is a powerful force and that it must be treated with respect. By following safe work practices and adhering to the NEC, it's possible to work with electricity safely and effectively. In addition to the code requirements, consider the recommendations and best practices of industry organizations such as the National Electrical Contractors Association (NEC) and the Institute of Electrical and Electronics Engineers (IEE). These organizations provide valuable resources and guidance on electrical installation and maintenance. Staying up to date on the latest industry trends and technologies can also help improve the performance and safety of the electrical system. Consider attending industry conferences and training events to learn about new products and techniques. This can help ensure that the electrical system is using the most efficient and effective technologies available. When designing and installing electrical systems, it's important to consider the environmental impact. Choose energy-efficient equipment and design the system to minimize energy consumption. This can help reduce the building's carbon footprint and save money on energy costs. It's also important to properly dispose of any waste materials generated during electrical work. Recycle materials whenever possible and follow all applicable regulations for the disposal of hazardous materials. By considering the environmental impact of electrical work, it's possible to create a more sustainable and responsible building. Remember that electrical safety is everyone's responsibility. By following safe work practices, adhering to the NEC, and staying up to date on the latest industry trends, it's possible to create a safe and efficient electrical system that meets the needs of the building and its occupants. Furthermore, the evolution of electrical codes and standards are an ongoing process. Staying informed about the latest revisions and updates is crucial for ensuring compliance and maintaining safety. Subscriptions to industry publications, participation in continuing education courses, and membership in professional organizations can facilitate this ongoing learning. Consider the potential for future expansion or modification of the electrical system. Designing the system with flexibility in mind can simplify future upgrades and avoid costly rework. This might involve installing larger conduit sizes, providing spare capacity in panels and raceways, or selecting modular equipment that can be easily expanded. Regular inspections and testing are essential for maintaining the integrity of the electrical system. Infrared scanning can identify hotspots and potential failures in electrical connections. Ground fault testing can verify the effectiveness of ground fault protection devices. These proactive measures can prevent costly breakdowns and ensure the safety of the electrical system. When selecting overcurrent protection devices, consider the coordination and selectivity of the devices. Proper coordination ensures that the device closest to the fault will trip, minimizing the impact on the rest of the system. Selectivity ensures that only the affected portion of the system is energized, allowing the rest of the building to remain operational. Surge protection devices, SPDs, are essential for protecting sensitive electronic equipment from voltage surges caused by lightning strikes or other electrical disturbances. SPD should be installed at the service entrance and at critical branch circuits to provide comprehensive surge protection. Consider the impact of harmonics on the electrical system. Harmonics are nonlinear currents that can cause overheating of transformers, conductors, and other equipment. Harmonic filters or line reactors can be used to mitigate the effects of harmonics and improve the performance of the electrical system. Power quality monitoring can provide valuable insights into the performance of the electrical system. Monitoring voltage, current, harmonics, and other parameters can help identify potential problems and optimize the operation of the system. Emergency power systems, such as generators or uninterruptible power supplies, UPSs, are essential for maintaining critical functions during power outages. Emergency power systems should be regularly tested and maintained to ensure their reliability. Consider the use of renewable energy sources, such as solar panels or wind turbines, to reduce the building's reliance on the electrical grid. Renewable energy sources can help lower energy costs and reduce the building's carbon footprint. Smart grid technologies, such as smart meters and energy management systems, can help optimize energy consumption and improve the efficiency of the electrical system. Smart grid technologies can provide real-time data on energy usage and allow for remote control of electrical devices. Consider the integration of building automation systems with the electrical system. Building automation systems can control lighting, HVAC, and other electrical equipment to optimize energy efficiency and improve occupant comfort. Cybersecurity is an increasingly important consideration for electrical systems. Protect the electrical system from cyber attacks by implementing appropriate security measures, such as firewalls, intrusion detection systems, and access controls. The NEC includes provisions for arc flash protection, which is designed to protect workers from the hazards of arc flash events. An arc flash study can help determine the appropriate level of arc flash protection for different areas of the electrical system. Labeling of electrical equipment is essential for safety and maintenance. Clearly label all disconnects, panels, and other equipment to identify their function and voltage. This can help prevent accidents and ensure that the electrical system is properly maintained. The NEC requires that electrical systems be properly grounded to provide a safe path for fault currents. Proper grounding is essential for preventing electrical shocks and ensuring the reliable operation of electrical equipment. Bonding is the process of connecting all metal parts of the electrical system together to create a low impedance path for fault currents. Proper bonding is essential for preventing electrical shocks and ensuring the safety of the electrical system. The NEC includes provisions for the use of flexible cords and cables. Flexible cords and cables should be used only for their intended purpose and should be properly supported to prevent damage. The NEC includes provisions for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where flammable gases, vapors, or dust may be present. Electrical equipment installed in hazardous locations must be specially designed and approved for use in those locations. The NEC includes provisions for the installation of electrical equipment in wet locations. Wet locations are areas where water or other liquids may be present. Electrical equipment installed in wet locations must be specially designed and approved for use in those locations. The NEC includes provisions for the installation of underground electrical wiring. Underground electrical wiring must be properly buried and protected from damage. The NEC includes provisions for the installation of overhead electrical wiring. Overhead electrical wiring must be properly supported and cleared from obstructions. The NEC includes provisions for the installation of electrical equipment in healthcare facilities. Healthcare facilities have unique electrical requirements to ensure the safety of patients and staff. The NEC includes provisions for the installation of electrical equipment in data centers. Data centers have unique electrical requirements to ensure the reliability of critical IT equipment. The NEC includes provisions for the installation of electrical equipment in industrial facilities. Industrial facilities have unique electrical requirements to ensure the safety of workers and the reliable operation of industrial equipment. By considering all of these factors and staying up to date on the latest codes and standards, it's possible to design and install electrical systems that are safe, efficient, and reliable.